Okie dokie. Let's see who's here and who's not. If you are on, can you pop your name in the chat box for me? Let's start with 5C. Don't seem to have anyone at the moment, so bear with. Okay, got 3 people. Brilliant. Let me just write down what we're going to be doing. So we'll be looking at from page 41 onwards, and it's the start of chapter 3. I want to do one of the questions from coding. Somebody emailed me and asked me for a solution to 5C. So I'm going to do that before I go any further, and then we're going to move on to chapter 3. The goal by the end of like this lesson, next lesson, and the lesson after, like, you know, the homework over Easter, is to finish this, and that means we've finished all the content. Okay? So the goal of today, tomorrow, and the Easter holiday is to finish chapter 3 in the applied textbook. So that's from page 41 onwards. Then we've finished all content, and then we're going to do different stuff after Easter. Part of it will be some revision, but we'll also be doing some different project-based work, different types of work, because we can't really assess you. We can't examine you. Well, it can give you, like, we can try and give you exams, but it's not going to work in the same way, like sit down in a hall with formula booklets and all the rest of it. So we're going to have different ways of assessing whether you can move on to next year or not. So the goal for this, for today, for tomorrow, and over the Easter holiday is finish off chapter 3. But before we do that, I'm going to ask you to have a look at question 5C on page 35. So in general, we're doing chapter 3, but for now, it's 5C. I can't see that well. You can see this on page 35 because that was asked. And what's so special about that? We need to work out. I'm just going to wait a minute and give everyone a chance to catch up. Again, we're in the applied book. We haven't moved anywhere. We're still on the applied book. We're not going to do any pure content before Easter. And remember, that's today. We've got tomorrow, and then we've got a homework. On the point of the homework, I'll be checking the Dr. Frost homework online tomorrow, so make sure you've done it by then. Kausar, I know about you, all right? Leave it for now for this one. For the next one, you'll be signed into it, don't worry. I'm pretty sure you already know how to do it anyway, so not overly fast. Okay? So question 5C on page 35 of the applied book, if you haven't got there already, it's a question about light bulbs, the 70 light bulbs. And it asks you to estimate the standard deviation of the lifetimes of the light bulbs after doing a coding. And the coding is y equals x minus 1 over 20. But the table's different because it goes 20 to 22, 22 to 24, 24 to 26, 26 to 28, and 28 to 30. And the way you deal with that is by just using the midpoint. So my lifetime would go from 21. 21 minus 1 is 20. 20 over 20 is 1. Okay? So your lifetime, your coded value y would go 1, 3, 2. Sorry, my apologies, like 2. Because midpoint of 22 and 24 is 23. So, yep. So that would go, hold on a minute. 23 minus 1 is 22. So that would go 1.1. The next one will be 25 minus 1, so 24 is over 20, so it'll be 1.2. Good morning, good morning. So just showing you 5C on page 35 before we go any further. The next one will be 1.3. I don't know, 24, 26, 25, yep. So that's 27, yep, 1.3. And then the last one, 28 to 30, 29, 29 or 28, yeah, 1.8. 1.4, sorry, yeah? So that's your coded values for Y. And your frequency is obviously unchanged. 3. So just if anyone's just coming in and wondering what the hell I'm doing 5C worked example, just because somebody asked for it. And then I'll explain to you what we're covering today. 40, 10, and 5. All right. And then you've got a table, and then you just got to run your formula just like normal, which is, in this case, sigma. I'm just going to write out the formula that you should use. Sigma fy squared over sigma f. You can't see that all that well. I'm going to drag that up. So what you need to do to be able to acquire all of these numbers, you'd have to calculate what y squared was. So I'm just going to rub out, because we all know it's 5c now, hopefully. You have to get what y is. That's 1, so y squared, which is 1.21, 1.4, 1.69, 1.96. All right? And then just calculate what those numbers are. So sigma fy squared, you times f and y squared together, and then add them up. So this times this, plus this times this, plus this times this, so on and so forth. Sigma f is just add up your f's. Sigma fy, same thing. F times y, f times y, f times y, f times y, add them all up, divide them by sigma f and square it. So hopefully that will give you, the person who asked for 5c, it will give you enough working out that you can now do this question. And if you can't, just email me again, and then I'll show you that in more detail. But I reckon I've given you enough there that you can at least start the question. I guess the key point was finding the midpoint and then just being able to deal with the fact that the formula is dealing with y instead of x. All right, cool. So what are we actually doing today? So I've answered the question. By all means, email me questions anytime. If you ever need to ask a question, ask, by all means, I'll catch you up on the next video. So there's a bunch of people that have just shown up. We're down a few people. There's only like 10 people. Right, page is page 41 to start with. Yeah? Page is page 41 to start with. We want to finish, or I want us to finish, and it's still applied, look, chapter 3. All right? And chapter 3 starts with the concept of an outlier. Does anyone want to define in the chat box for me what an outlier is? Just pop something in the chat box if you know what an outlier is. We're down to 8 viewers, which is a bit worrying. I know it's early in the morning, but that's a bit, yeah, up to 9. Maybe, I don't know, maybe it's Wi-Fi or whatever. So anyone pop in the chat box what they think an outlier is. If you don't know, it's fine, no problem. I'll explain it. Hey, Harley, good to see you. Inside the critical region, I'm going to use that kind of thinking. I'm not going to lie, Dante. I'm going to use that sort of idea. But inside, I will disagree with. No worries, not this. We're all in a very weird situation right now. There's no doubt about that. So I'm going to give you about another 30 seconds to come up with a definition if you can. Doesn't go with the trend of the data? Yep, absolutely. That's almost exactly the right answer. There will be a boundary, and we're going to show you how to calculate that. You're right, Dante. Really good on that one. To be an outlier, you have to define how strange do you need to be an outlier. Yeah, I mean, I think we've got that. Okay, so the official textbook definition is it's an extreme value that lies outside the overall pattern of the data. So you find that definition on the top of page 41. An outlier is an extreme value that lies outside the overall pattern of the data. So basically, it's a bit like, your binomial thing. We have to be so extreme that we reject the null hypothesis. It's a bit like that. And to be an outlier, you have to be not fitting with everything else. And there's generally a calculation, okay, that you need to do, which is you're going to say, well, if you're outside this range, you're an outlier, okay? Now, the problem is they just don't always use the same definition. They generally use this one, which is you work out, so your method, and we'll just give you a method here step by step. So method, find your lower quartile, yeah, and your upper quartile, and your interquartile range. So anyone would have any problems finding lower quartile, upper quartile, and interquartile range? Remember, we covered that maybe a week or so ago, maybe a bit more than that. So lower quartile, upper quartile, and interquartile range. Anyone's got any particular problems with that, I want you to flip back and first of all tell me, and then when we do it together, I'll remind you of it. Okay? Calculate some number, and they'll tell you what the sum number is, times the interquartile range, all right? And the sum k is some number. All right? And your step number 3, take this, minus it from the lower quartile, and add it to the upper quartile. And if that sounds confusing, just for the minute, take the notes and I'll walk you through how this is done, because it's really not hard at all. And the example I'll do is I'll do example 1. All right? Okay, so I'm going to give you about 30 seconds to write that as like, this is my method of finding outliers. Then we're going to go through finding outliers. Okay, give that about another maybe 15 seconds just to copy that. So your method, find your lower quartile, upper. So the definition, the outlier is an extreme value that lies outside the pattern of the data. So basically, imagine all your data saying one thing and then you've got one piece of data that's saying something else. So for example, if most students are doing well, but you have somebody who's really, really struggling, that person would be an outlier. But there's a mathematical definition for it. And I'm going to show you how to calculate which is an outlier. You can't generally just look at it and go, oh, that's an outlier. Yeah? Because obviously you could be biased. It might be that that teacher is, I don't know, prejudiced against one student, and that's why they're failing. So you can't just kind of just say it's an outlier. It might be because they've chosen to do that. All right? So what I'm going to do is I'm going to take you through example 1 in about 15 seconds. I'm just looking ahead at the book. I want you to be just to get ahead to an idea of what I'm asking you to do. 3A, 3B, 3C, because like all of this stuff is stuff you've done before. It's literally this, then box plots, which you learned from GCSE, hopefully, and then cumulative frequency, which you also learned from GCSE. Then Thursday's lesson will be on histograms, and if I remember correctly, something about comparing data. And then we've literally finished the first year course. And what we're going to do after that, after Easter, is going to be very, very different. All right? We're going to change up a lot of things. But for today and tomorrow, we're going to finish the course. All right? People have been asking about whether there's going to be mock exams. The mock exams are going to be in September, so you need not worry about that. That means obviously we're going to have to find different ways of assessing whether you know enough to carry on the course, and that's what we're going to be concentrating after Easter. All right? So we good? Let's do this. So example 1 is the one I'm going to do. All right, I'm going to do example 1. Example 1 as follows. The blood glucose, so you've got this whole list of blood glucose. An outlier, so they've defined their outlier as 1.5 times the interquartile range, okay? So the first thing you need to be able to do is find the lower quartile and the upper quartile. And do you remember all that stuff about dividing by 4 and rounding up? 3/4 is being 3 over 4 and rounding up. So go back to your notes and remind yourself how quartiles work, right? If you want it quickly run down for you, let me just pop it on the whiteboard, so it might save you a bit of time. The rule is as follows. You round up, so you divide by 4, yeah? So for lower quartile, you divide by 4. If it's a whole number, then you pick the midpoint of that number and the number above it. So if it was, say, let's do 8 divided by 4 is 2, you'd find the second number and the third number and find the mean of the second and third number. All right? If it's not a whole number, for example, if it was 9 divided by 4, which would be 2.25, you always round up. And it's the same thing with the upper quartile, but instead of dividing by 4 only, you're going to divide by 4 times by 3. All right? So 3/4. All right, so just a quick reminder how you do that. So when you're dividing, lower quartile, you divide by 4. Upper quartile, you divide by 4 times by 3. If you happen to get a whole number, pick that number and the one above it and work out the mean. If it's a decimal, you round up to the next number. So even if it was literally 2.25, you'd round up and pick the third number. All right? Hope that makes sense. Beautiful. So just a quick reminder how that works. So I'm not going to do actually I'll do it because it's relatively easy. So if you look at example 1, there's 30 of them. I'm just going to pop the 1.5 back again. 1.5 times IQR. I'm going to change up my pen in a second. Okay, so what's that saying to you? 30 numbers, 30 divided by 4 is 7.5, so you're going to pick the 8th number. And if you read along, your 8th number should come out as 3.2. So your lower quartile is 3.2. Then you've got the next one, which is your upper quartile. So again, 7.5, 30 divided by 4, times by 3, 22.5. So you pick the 23rd number. And if you count across, your 23rd number is 4. So far, so good, I hope, right? The next thing I told you to do, how did I get 3.2? I did 30 divided by 4, which is 7.5. Then I counted 8 numbers. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah? My 8th number in the list of example 1 is 3.2. If you can't see the textbook, I mean, you have to see the textbook for this one, because there's no way I can copy out 30 numbers, all right? So if you need a second just to look it up, it's page 41 in the textbook, the one we're using, all right? So you can't see that one. I hate this camera sometimes. Page 41, yeah? So yeah, 3.2 comes from the data that I'm given on page 41. If you need a minute to open up your textbook, can you drop a message in the chat box and I'll wait for you, because it's really super important that you've got the data in front of you when you're talking, because otherwise this example will make literally no sense. Got it, excellent, good. So if anyone else is in that same boat, you will need your textbook for today's lesson and tomorrow's lesson. All right, just be aware. To be fair, you've needed it for every single lesson, so nothing new there. Okay, so page 41. If you look at the data, the 8, you do 30 divided by 4 is 7.5. 7.5 number is 8, rounds up to 8, so you pick the 8th value. 3/4 of 30 is 22.5. 22.5 rounds up to 23. Pick the 23rd number, that's 4. You also, if you look in the example, they also asked doing the median. I actually don't need it for my outliers, so I'm not going to bother doing it, but it'll be exactly the same thing. 30 divided by 2 is 15. Pick the 15th and the 16th terms and do the mean of it. Okay? Now, so the next thing I was supposed to do, if you remember your method, if you copy down the method, it was you need to work out your interquartile range. Okay? So your interquartile range is 0.8. All right? So interquartile range, 0.8. Superb. Now, the next thing I'm supposed to do after that is multiply it by 1.5. So here in the question, they've said an outlier is an observation that falls either 1.5 times the interquartile range above or below. All right, so I do that. So I do 0.8 times 1.5, which should be 1.2, if I remember correctly. Yeah, 1.2. Superb. Yeah. So what do I do with that 1.2? I take it away from the lower quartile, so I've got 2, and I add it to the upper quartile, so I get 5.2. Any number between 2 and 5.2 is not an outlier, okay? So you need to be smaller than 2 or bigger than 5.2 to be an outlier. And that's it, all right? So if I look at my data, 1.7 is an outlier, and that's it, yeah? If you look at the data, the only number smaller than 2 is 1.7, and there is no number bigger than 5.2. So therefore, no outlier. Now I'm going to stop talking now. Anyone's got a question, pop it in the live chat. What happens if it's exactly 2? You keep it. Because it's greater than or less than, not greater than or... Yeah, so if it lands exactly on 2 or 5.2, you keep it in the data. You keep it in the data. No worries. Anyone else got a question? I'm not going to talk for another 40 seconds. There's still a couple of things I need to teach. And then that's us done for today. Reminding you that I want you to cover for me, briefly at least, 3A, 3B, 3C. But I've still got some... I'm not finished teaching here. Because 1.2 minus... No, it's the other way around. It's the lower quartile minus 1.5 times the interquartile range. Yeah? So yeah, just to be clear on it, the formula is LQ minus number and GQ plus number that way around. Thanks for asking, Rashida. Good question. Yeah? So it's this way around. So you get your lower quartile and you take 1.2 from it. You get your upper quartile and you add 1.2 from it. Sorry if that wasn't clear. All right. So I'm going to briefly look at example 2. Example 2 is not much different in that instead of doing an outlier by doing quartile ranges, do an outlier with standard deviations. But other than that, it's not much different. So I'm going to have a quick look at example 2. Then I'm going to talk to you about cleaning data, and then we're done. So let's quick look at example 2. Example 2 is on page 41, that goes on to page 42. All right, I'm just going to rub this out now. So we're looking at example 2 now. I need to really clean this. So example 2, and it's on both page 41 and it stretches on to page 42. And it's about snails. That's what we do. It asks you to work out the mean and standard deviation, and I assume you can do that now, so I'm just going to move straight on to that. So we know that the mean, I'm not going to recalculate that unless anyone really needs to see the mean and standard deviation done again. But hopefully we're comfortable with that by now. Yeah, so mean 21, standard deviation 3.83. All right? But they use a different definition of the outlier this time. They say an outlier if you're outside 2 standard deviations from the mean. So you take your mean and you take away 2 standard deviations, and you take your mean and you add 2 standard deviations. And those give you your new bounds. So that would be 21 minus, what would that be? 7.66? 38, 38, 76, yeah. So this will be 21 plus 7.66. And you add, this one is going to be 28.66. This one, it would be 13.34. Let's see if I've got that right. Yes, good. So basically any value that's less than this or more than that is an outlier. Remember, if you're inside the range, you're comfortable, all right? And here for this one, in terms of our snails, the only one that can be called an outlier is the 32, I think. Yeah, the 32 is an outlier. So you see that this can be done with standard deviations as well. It's the same idea. You establish what range is, and remember, if you're inside the range, it means you are not an outlier. And once you've worked out what your range is, it shouldn't be too bad. You just go, okay, is any of the data outside this range? If it is, it's an outlier. Okay. Again, I'm going to give you about another 40, 50 seconds. Anyone want to object to example 2? The mean and standard deviation, I assume you can do. They then tell me that standard deviation, the definition of an outlier is plus or minus 2 standard deviations, which will come back to haunt us next year. So I work that out, make myself my range, and then look, is anything or any piece of my data outside that range? If it is, it's an anomaly. It's an outlier. Anomalies are what we're going to do next. I'm kind of thinking ahead there. You've got about another 35 seconds to make an objection about anything you've seen so far. All right? I'm going to stop here just for a minute. Then I'm going to talk about that word I just said, anomalies. Let's have a look if there's anything interesting in box plots. Nope, same old box plots. Cumulative frequency, same old cumulative frequency. Yeah, we'll start histograms tomorrow. Okay, unless anyone's going to say something, you've got 10 seconds. Pop something in the live chat if you want me to stop here. Because there's not much more I need to say. I've got like literally maybe 3 minutes more content now. I'm going to do registers and things like that. Okay, let's roll. Right. There's a new word I want to define, and that's called anomaly. All right. Sometimes you have outliers. They happen, right? You all think about if you think about your primary school kids, all about same height, and you got this guy, one guy, or one girl who's really super tall. Well, they exist. So outliers happen. But if an outlier has come because there's been a mistake, someone's made a mistake in measurement, or it's just a lie. For example, if I said to everyone, how much money have you got in your bank account? And everyone gives me honest answers, and then someone pops up and says, I've got £4 million. That would be an example of an anomaly. It's an outlier that's not based in reality. All right. So if you've got a data value that is both an outlier, but it's an outlier because it's an error and it would be misleading to keep it in, that's the wording of the textbook, then you call that an anomaly. Hopefully nobody's confused by that definition. Outliers happen in real life, okay? As we saw with the binomial distribution, they happen sometimes. But if the outlier has come about because of a mistake of some sort, then we can call it an anomaly. And if we've got an anomaly, we can clean the data. Yeah? And we clean the data. That definition of that, cleaning the data, means get rid of the anomaly. All right? Obviously, you've got to be super careful with this. Exactly, Dante, that's a really, really good question. Let's answer that. What happens if it's not like, this is the risk you take when you remove an anomaly. You've got to be damn sure it is an anomaly. Yeah? Because otherwise you're biasing the data yourself. Yeah? So you hit the nail on the head there. You can't just go, oh, it's an outlier, therefore it must be an anomaly. You might be super rich. For example, going back to the kid that's got 4 million at their bank account, that might be a true thing. And you'd be wrong and you'd be messing the data. You'd be cheating to get rid of it. It's like a teacher going, okay, everyone got 50, 60%. Somebody got 2%. That kid's an anomaly. Well, what if they really did get 2%? I mean, all you're doing is biasing the data at that point. All right. So you've got to be super careful. All right. When you're going to label something as an anomaly, especially to get rid of it. Yeah. If you are going to say something's an anomaly and you're going to clean the data, as in get rid of that piece of data, you need to offer a justification why. So you might get things like, I don't know, if it was rainfall, something like 4 meters of rain fell. I mean, that can't happen. Otherwise, like London would be underwater. Something that's obviously wrong. Yeah? Obviously impossible. Okay? Or just incredibly, incredibly improbable with a reason. So just be aware. An outlier that's come about because of an error is called an anomaly. Getting rid of an anomaly is called cleaning the data. And that's all you've got to know. So we're done here. What do we need to have ideally? I want people to do a bit of 3A, a bit of 3B, and a bit of 3C. And for those last two, you only need to do, I'd say, 1 each. Because this guy is box plots and that guy's cumulative frequency. And that's literally GCSE stuff. 3A, I'd spend most of my time. Your homework is on Dr. Frost unless you're Kausa. Kausa, I'm going to rejoin you the class tomorrow because it's literally, I have no clue what's going on with your life. It's not even your fault. I don't even know what's going on with Dr. Frost. So you'll get all the other homeworks. We will start again tomorrow looking at 3D, which is histograms. And histograms does change up from GCSE. All right? I'm going to hang around here for another 2 minutes, as I always do. So if anyone's got any particular questions, pop them in the chat box. But otherwise, that's me done for today. Hope everyone's well. Take care of yourselves. Any issues? You have not added you as well. I'm pretty sure. Okay, Demetrius, I'm pretty sure I did. Try logging in with your email and password of password. All right? Okay, no problem, Dante. If you've got the same problem, can I ask you to do what Kausa did and email me a different email address, not a college one, and you'll get it through that. Thank you, my dude. Yeah, 3A, B, C. Majority 3A, maybe 1 each from 3B, 3C. Because, like, I'm guessing, unless, like, you know your weak spot in life is cumulative frequency, anytime, Jacob, anytime. And as I said to everyone, hopefully we're going to be done we'll finish year 1 content today. Not today, tomorrow. No problems there on. And we're going to do a lot of different things after Easter. Doesn't look like we're going to be getting college back before September. Yes, my dude, thank you. I really appreciate that. Fazana, same to you. You look after yourself. I'm going to hang around here for about another minute or so, just in case anyone's got questions. Obviously, I'm on Microsoft Teams. And as you saw, if you email me a question, I'll answer it in the next live stream. Let me pop the register up. That might be a shout. Okay, cool. All right, Aziza. No problem, sorry. I'm off now. Take care. Have a lovely day.